let's talk about slopes. Look at the ground as if it's a surface, in fact like the graph of a function of two variables. The question is, from where I'm standing, what is the slope? Well, that depends on what direction I'm looking, right? If I move north-south, then I'm moving along level ground. It's like I'm walking along a level curve, and my slope is basically zero. However, if I start looking east-west, and I start going straight up the hill, then now my slope there is much larger. And so your slope depends on what direction you're looking. In fact, there's not just the north-south or the east-west, but other types of slopes as well. For instance, if you had a road that you needed to get up to the top of a hill, then you could go straight up the hill, but if that's too steep, you've seen many roads where they zigzag. They go along a route like this, zigzagging until they get to the top of the hill, with the idea that the slope that you're moving on is less than if you went directly straight up the hill. So we have a lot of options to move. So the question is, how are we going to find these slopes? Well, we can find the slope here in the north-south direction by just looking at the path that I'm walking along. Where you don't care what's to the right and you don't care what's to the left, all you really care about is that path upon which you're walking. And so if that path is thought of as that slice, then you're looking at a curve then instead of a surface, and then you can find your slope just the same way you would finding the slope of a tangent line. So that will be our strategy. We will look here at our surface, we will slice it in the north-south direction or the east-west direction, and when we slice, we'll have a curve, and we'll find the slope of the tangent line of that curve. That will be our slope.